Welcome to the session on discrete mathematics, an important branch of mathematics. It is a core course for BTech, BE in computer science offered by most of the universities. The components of this course at different levels are offered to undergraduate and postgraduate mathematics students by many universities. Now, some of the important topics that will be normally covered in this course are logic, relations, combinatorics, order relations, grammars, languages, and automaton. In this session, we shall discuss grammar, a part of the theory called theory of computation or formal languages and automata theory. This theory of computation started in the year 1959 with the formal definition, that is, a mathematical model of a grammar given by Noam Chomsky. Now, let us use parse tree of the natural language structure to define what a grammar is. We know very well every language has a grammar, so we can consider a simple example and we can construct parse tree for the same. Consider the English sentence, the students learn grammar. We know the is an article, students is a noun, learn is a verb, and grammar is another noun. We can combine article and noun 1 and call it as noun phrase. Verb and second noun can be combined and can be called as verb phrase. Now we will complete this as a tree with the use of a start symbol. Here the start symbol is denoted by S. You can see that S splits into noun phrase and verb phrase. Now this noun phrase itself splits into article and noun 1, where the article is the and the noun 1 is students. Similarly, verb phrase is splits into verb and noun 2, where verb is learn and noun 2 is grammar. We are going to make use of this structure and we will rewrite in a different form, like yes is rewritten as noun phrase and verb phrase, where the noun phrase is rewritten as article and noun 1, where article is rewritten as the, noun is rewritten as students. Similarly, verb phrase is rewritten as verb and noun 2, where verb is learn and noun 2 is grammar. All these objects are in the form alpha gives beta or alpha produces beta. We use this symbol to denote rewritten as. Now look at all these objects. These are similar to some rules, and so we call them as production rules, and it is denoted by capital P. if we look at different production rules and their objects, we can observe that some of the symbols produces some symbols further and some does not. For example, S produces NP VP, NP further produces article and N1, article also further produces the. Similarly, noun 1 further produces students. We can apply the same argument for the rest of the production rules also. The objects which produces further like S, NP, VP, article, N1 are known as non-terminals, which does not terminate the process. It is denoted by capital N. And the objects, the students, learn, grammar, terminates the process, and so they are known as terminals, and they are denoted by capital T. Using all these production rules and starting from S, we have this derivation, that is S directly derives NP VP, noun phrase verb phrase, where NP directly derives article noun 1, article directly derives the, noun 1 directly derives students, verb phrase directly derives verb and noun 2, verb directly derives learn, N2 directly derives grammar. So yes, indirectly derives the students learn grammar. We use this symbol to denote directly derives, and in total, yes, derives the students learn grammar after a finite number of steps, that is arbitrary number of steps. Arbitrary number may be 0 or any number n. So generally alpha dash derives beta dash after an arbitrary number of steps. So we have these elements, that is a set of non-terminals, a set of terminals, a set of production rules, along with a specific component called start symbol S. So with these four elements, we define grammar formally as G, a fourth tuple NTSP, where N is a finite set of non-terminals, T is a finite set of terminals, where N is a finite set of non-terminals, S is the start symbol, which is also an element of N, and a set of production rules capital P. Some conventional notations are, for non-terminals, we use uppercase alphabets S, A, B, C, X, Y, etc. For terminals, we use lowercase alphabets A, B, C, etc., numerals 0, 1, 2, etc., and symbols like minus, plus, hash, etc. So now we are ready to present an example of a grammar G with a non-terminal S, a terminal T with two symbols A and B, where S is the start symbol, and the production rules S gives ASB and S gives AB. Here both ASB and AB are strings where ASB produces further strings and AB terminates. Let us see the language produced by these type of grammars after the formal definition of language. Thank you.